Lesson 2-3, absolute value equations. First, let's review absolute value. You may remember that absolute value is the distance from 0. Therefore, it is always positive. Distance cannot be negative. The absolute value of 7 is 7, and the absolute value of negative 7 is 7. The absolute value of 32 is 32, and the absolute value of negative 32 is also 32. And we can use this to solve equations with the absolute value of a variable. So if we have a variable by itself inside of the absolute value bars, the absolute value of x is 5. We know that the absolute value of 5 is 5, and the absolute value of negative 5 is also 5. So that means x could be either 5 or negative 5 and give us a correct answer. We don't actually know which one it is, so the absolute value of x equals 5 gives us the following solution, that x is 5 or negative 5. This or is very important because it can be either or. So in order to solve equations with absolute value, for example, the absolute value of x plus 7 is equal to 19, first we have to get the absolute value of x by itself just as if it were an x. We do that by subtracting 7 from both sides, giving us that the absolute value of x is equal to 12. Then I solve for both values of x. Since we don't know which x is, x could be 12 or negative 12. I need to include both of these. Absolute value equations will always give us two solutions or no solutions. We'll discuss that momentarily. Some more examples with x by itself. I have 3 times the absolute value of x is equal to 36. So just as if I were using a regular equation, I'm going to divide both sides by 3 to get the absolute value of x is equal to 12. So x will be 12 or negative 12. 4 times the absolute value of x minus 10. I have multiplication and subtraction, so I undo the subtraction first. I get 4 times the absolute value of x is equal to 32. Then divide both sides by 4. The absolute value of x is equal to 8. Therefore, x will be 8 or negative 8. Again, you have to list both possible solutions. Here I have 3 times the absolute value of x plus 19 equals 4. I subtract 19 from both sides, and I get that 3 times the absolute value of x is equal to negative 15. Dividing by 3, I get that the absolute value of x is equal to negative 5. Absolute value cannot be negative. It is always positive. Therefore, if I have absolute value equals a negative number, no matter what that number is, there will be no solutions. But you want to be very careful, because just because we have a negative over here does not mean there will be no solutions. We have to isolate the absolute value first. So I'm going to add 3 to both sides. I have negative 2 times the absolute value of x is equal to negative 6, still negative, but when I divide by that negative 2, I get a positive 3 telling me that x will be 3 or negative 3. So just because you see this, you have to make sure that it doesn't stay, or that it stays negative. If its absolute value equals negative, you have no solution. But if there are other things happening, you have to get the absolute value alone first. Now sometimes you'll have more than just a variable inside the absolute value bars. So for example, I have x plus 3 equals 5. Well, again, we know that the absolute value of 5 is 5, and the absolute value of negative 5 is 5. So that means that x plus 3 can be 5 or negative 5. That means we have to set x plus 3 equal to both 5 and negative 5, which means we've split it into two equations to solve it. So here's what we do. First step is to isolate the absolute value if necessary. We want to make sure this is by itself, which it is. Then split it into two equations. So I have x plus 3 equals 5, or x plus 3 is equal to negative 5. Then I solve each equation separately. Oops, that was bad. There we go, never happened. Subtract 3 from both sides, x is 2. Subtract 3 from both sides, x is negative 8. Then I set both equal to x. So x is 2 or negative 8. Here are a couple more examples. I have absolute value minus 7, so I want to get rid of that minus 7 by adding. Now I have absolute value by itself, so I split into two equations. So 2x plus 3 is equal to 21, or 2x plus 3 is equal to negative 21. Subtract 3 from both sides, 2x is equal to 18. Divide by 2, x is equal to 9. Subtract 3 from both sides, 2x is equal to negative 24. Divide by 2, x is equal to negative 12. So x is equal to 9 or negative 12. Now when the x is by itself, you get the same answer, a positive and a negative. If you have a plus or minus in here, you get two separate answers. Here I have multiplication, so I'm going to divide both sides by 3. Absolute value of 4x minus 5 is equal to 4. Split it. 4x minus 5 is equal to 4, or 4x minus 5 is equal to negative 4. Add 5 to both sides. 4x is equal to 9. Divide by 4. X is equal to 9/4. Perfectly acceptable to have a fraction for an answer. Add 5. 4x is equal to 1. Divide by 4. X is equal to 1/4. And if you want, you can write the word or in between and circle both solutions. That would work as well. Here I have both multiplication and addition, so I subtract 10 first. Then divide by 2. Then split. Add 6 to both sides, I get x is 17. Add 6 to both sides, I get x is negative 5. And I combine my answers. Subtract 2 from both sides, I get negative 5 times 3x plus 6 is equal to negative 15. Now, I have a negative and a negative. I have to divide both sides by negative 5. I get 3x plus 6 is equal to positive 5. And actually, while I'm thinking about it, I want to address something. You'll notice that I did not do distributing. There is no distribution with absolute value. And think about when you had a parenthesis and you distributed, it has like a nice curve so you can slide in. Absolute value is kind of like a big giant wall. You can't go into it. You just run into the wall. So maybe that will help to remember not to distribute. You have to just divide. Okay, so I have split it. Sorry to jump around like that. Subtract 6. Divide by 3. Subtract 6. Divide by 3. And again, I've got fractional answers. That's perfectly acceptable. Just remember to put that word or in between. And that's absolute value equations.